My name is Alinur and I'm an engineering manager at Meltwater, based in Berlin, Germany. Our team has been juggling between several programming languages and frameworks for quite some time. At the start of this year, 2022, we have decided to greatly simplify our tech stack and work towards a single solution, that is Java. This presentation is about understanding how we ended up in this situation, what were some of the pros and cons of working with multiple tech stacks, and what concrete steps we're taking today for a successful transition to Java. Let me start off by describing Meltwater engineering teams. Our teams are known for being autonomous. What this means is that we can choose to work pretty much with any tech stack we want. We can customize agile methodologies, define any other team protocols to better serve our individual team needs. Now, this kind of freedom is obviously great, especially when it comes to running a team, making the team effective and productive, given the set of skills within that team. But when it comes to the actual technology, right, we have to face some harsh realities when dealing with multiple tech stacks. So the constant context switch combined with component handovers ultimately put this team on an unsustainable path. Component handover is when one team transfers the ownership of the component that they have built to another team. Now, this can happen for a number of reasons. The most popular one is a team's mission changes. They're focusing on a different product area, and it no longer makes sense for them to own what they built. Then it's given to another team where it fits better. Or it could be that we're simply shuffling engineering resources around and there's no team left to maintain that particular product. Component handovers, they don't happen all the time, but they do happen. And when it does happen, you need to be ready for it and accommodate. So let's take a step back and try to understand how we ended up in this situation. At the beginning of 2017, we were the owners of a single Ruby on Rails monolith. Around the same time, Elixir was up and coming. It's a language based on Erlang and has a very similar look and feel to Ruby, even though they're fundamentally very different. So we started experimenting with this and building new stuff. And around the same time, we had a component handover, a Java 8 backend service. Made a lot of sense from a business perspective that we own it. So we were very accommodating and we took it. And there were some new business requirements where we had to build a public-facing web application. And for that, we picked AngularJS, TypeScript. As you can see, within the span of 1 year, we went from 1 to 4 tech stacks. 2018 was a year of just building with its ups and downs, trying to overcome learning curves and the difficulties of adapting to new languages. 2019 was sort of a turning point as well, where some of the team members left the company, and the remaining team was mainly composed of Rubyists. Just historically, they had a lot more experience with Ruby. So naturally, the focus had shifted back to Ruby. 2020, we had a Kotlin this time component handover. Again, this is something that fit within our mission really well. 2021, another Kotlin handover. A team kind of dissolved into other teams, and we took the service that, again, made sense within our mission. 2022, we said, okay, this is too much to manage. We need to make some tough decisions, and we need to act on it. All right, so this was the final snapshot as of January 1st of this year. We had 3 Ruby, 6 Elixir, 3 Kotlin Java, so JVM, and 1 Angular JS. All right, now let's focus on the positive. What are some of the benefits of working with multiple tech stacks? First and foremost, your own marketability as an engineer. You get to put so many cool technologies on your CV. It opens up a ton of career opportunities. Gaining new perspectives. So this is basically discovering new ways of solving old problems. For instance, let's say you have been an object-oriented programmer your whole career, and now you're working with functional programming. So you are solving similar set of problems in a different way, and you might really enjoy how this problem you're working on is handled within the functional framework. So it's just giving you more tools, and it improves your problem solving technique. Learning. So this environment is a perfect environment for those who are excited about the process of learning rather than outcome. These type of engineers, right? They thrive in an environment like this, just facing new challenges every morning. Now let's talk about the disadvantages. Context switch, I briefly mentioned earlier. Engineers have the desire to be good at everything, right? All languages, but they end up knowing a little bit of everything. You're not able to specialize in one thing, basically. People start to mix coding styles, applying paradigms or best practices of one language to another. And especially if you have some, unmaintained components, meaning there is not a ton of feature development going on, they're kind of forgotten, and you're unable to keep up with version upgrades. And when you do need to upgrade, you kind of tend to forget how things worked. So it takes a while to get up to speed again. Component handovers. Again, nobody wants to take over a technology that they're not comfortable with. Just imagine you're trying to give an Elixir component to a team who works 100% with Java. They want absolutely nothing to do with it, understandably so. This greatly extends the time it takes to hand over a component. It consumes both teams and just doesn't end with great success. Hiring and onboarding, you can imagine it is near impossible to find someone who satisfies all the things you're looking for. Even if you find somebody, it takes a long time to onboard them, get them to a state where they are ready to be on call for each distinct environment. So what happens when cons outweigh the pros? So we came up with this action plan. Number one, decide on a single tech stack. Number two, hire an expert who can help us or lead the way during our journey. Number three, lay the foundation. So again, with the help of the expert, right? So we need to make some early decisions, versions, build systems, testing frameworks, what have you, right? And maybe build some template repos so you can build services quickly off of that template. And it also helps the rest of the team to kickstart the project. And last but not least, curating training material. Yeah, I mean, the best way to learn something is actually to do it, right? To practice with it and to do it. But we needed some form of training, just like to cover the basics so that the team can kickstart things, and they have a certain level of like base, so that they're not completely lost. All right, now deciding on a tech stack. Java was our number one choice, Kotlin being our second. Java needs no introduction, right? It consistently remains as one of the most popular programming languages in the world. It's time tested, battle tested, amazing ecosystem, very active community. So it was not a hard decision. Java is also quite popular in Meltwater organization. We have a lot of teams who are solely on Java. And likewise, Spring Framework, Spring Boot to be specific, is the most popular framework in Meltwater. So we immediately got to interviewing and interviewed a lot of talented candidates, and we finally decided on a Java expert, Cemal, joined us towards the end of last year. After giving him a chance to settle down and complete his onboarding, we immediately decided on specifics such as versions, build systems, coding styles, all those things. And now for the next part of this presentation, I would like to hand over the microphone to Cemal so that he can share his side of the story and what concrete steps he took to help us transition to Java.
Hi everyone, my name is Cemal Kozanoğlu and I'm one of the senior software engineers in Team Maven. So as soon as I joined the team, one of the first things I did was trying to discover the state of the existing services we had. And I found out that we have a bunch of Java applications that had Java 8 and a bunch of Kotlin apps with an outdated version of Kotlin as well. And for me, it made sense to start with this, to make the effort to unify the JVM version that is shared across all these different apps. And therefore, we made the effort to clean up and structurally organize the existing apps. And at that point, we also made the decision to adopt Java 17. So in the company, we already have hundreds of services written in Java and also Kotlin. And there's an ongoing debate to understand which one is actually the better choice to go forward. And we had seen each, also having each in the team, we favored Java mainly. And the argumentation here was mostly better familiarity with Java language itself compared to Kotlin. So Kotlin is on its way to prove itself, whereas Java has already done this, like it's a very standard language with 30 years of history and development. So it's hard to make a mistake with a choice around Java. And at the same time, Java lately has been taking the correct steps to close productivity gap with Kotlin. And the addition of records, switch expressions, and some additional features in the more recent versions of Java definitely helped with this decision. Plus, also the project Lombok makes Java much easier to read and reduces the boilerplate. And knowing all this, we basically favor Java moving forward. But for the existing apps, we chose to migrate them to Java 17 as well, and the latest version of Kotlin, which was at that time 1.6. And when it comes to the tech stack for the newer apps, the choice was obviously Spring Boot for us, already having the experience with it and knowing that there's an enormous community of developers and learning material for it. And it's very easy to find the answers to any problems that we may bump. And yeah, Spring Boot was a very natural decision when it comes to building fast microservice frameworks. The next decision we took was about the build system, whether to use Maven or Gradle for that. So we know that Gradle is more modern and faster, and it has a DSL that is easier to read compared to Maven's XML, which looks pretty outdated by today's standards. On the other hand, Maven is more established. It simply gets the job done, and it is basically the industry standards. And according to the statistics from Stack Overflow, 70% of the existing projects are using Maven as well. In addition, Maven rhymes with Team Haven, so this is also another selling point for us. Jokes aside, it in reality boiled down to the composition versus inheritance debate that is also going on between Maven and Gradle. And in this case, we favored inheritance, knowing that we basically want to build a monorepo-like structure, meaning we want to have all our apps follow a similar templates with standard set of libraries and plugins that we want to use. So for this purpose, building a parent POM seemed like a very easy solution. Therefore, we favored Maven and we built a parent POM called Haven Spring Boot Parent. And this basically contained the Spring Boot libraries and additional bunch of test libraries, a bunch of utilities, and the plugins that we wish to use. Using the parent POM and the monorepo approach, we quickly get on speed with development of the microservices, and we built 2 services as the outcome of this effort. One of these were a typical Kafka consumer app, and the other was a typical API. And finally, we wanted to come up with a list of training material with the purpose of bringing all the team members up to speed with Java development. So we mainly targeted people here who already have software engineering experience with different languages like Ruby, Node.js, some Java, some Python. And these people were not so much familiar with Java-related concepts like object-oriented programming concepts, for example, interfaces, abstract classes, generics in Java, the Maven build system, building microservices using Spring Boot, then unit testing specific to Java, JUnit, and mocking frameworks like Mockito, for example. So the team had to get familiarity with these. Therefore, the training material was oriented around like this kind of things. And also some common Java misconceptions and gotchas, and the key differences between Java and the other languages. So with the curated material, the members spent some time watching the videos and reading the helpful articles to train themselves, and they got on speed with development, and they took part developing the 2 microservices that I mentioned before. And so they were easily able to get on board with Java development, if we can say that. Lastly, Alinur will talk about the next steps we took. Thank you.
Hi again, and thank you, Jamal, for that great presentation. So, what are the next steps for us? Well, clearly, going forward, all new components will be written in Java. As for the old ones, our mentality is, if it ain't broken, don't fix it. In other words, we're not going to rewrite anything just for the sake of rewriting it. If a component is running fine and there's not a ton of active development on it, we will keep it as is. Evangelizing the importance of a unified tech stack within our organization by sharing our experiences, our struggles with other teams so they don't make similar mistakes. And of course, lastly, we will help any team in a similar situation. We'll help them transition to Java. We have acquired a lot of knowledge through this process, and they're all worth sharing. This concludes our presentation. Thank you so much for watching. Please leave your questions down below in the comments, and we'll get back to you. Thanks so much again, and until next time, take care.